So we sent that post request, and there's the file, and it should be on our server. There we go. That actually worked. Surprising. Yeah, me too. I'm just as surprised as you are. So now we're going to talk about files. Now files are a higher level interface, or lower level depending on how you're looking at it, that extend from the blob interface. So a file is everything that a blob has, but it also gets other stuff. It has this name property, which, as you would expect, is the name of the file. It also has this last modified date property. I think we can figure out what that means. Other than that, there aren't any other methods added to the prototype of blob. So the main takeaway is that a file, there's two takeaways. One is that the file has this sort of name property, and whereas blobs, generally speaking, will represent maybe bytes in memory, not necessarily bytes on disk, a file is always going to represent bytes that are on disk, on storage somewhere. So when you have access to a file object in the browser, that will be sort of like a pointer to an area on disk. It's not going to be something that you would have like load into memory and you have to worry about consuming your resources there. So one of the things you get with the file object, with the file interface, is a better input type equals file, a better file input element. So on the HTML input element host object, you get a files property. And a files property, the type of that is a file list. And this can sort of bite you. File list is not an array, even though it's a pseudo array. There's a lot of those things in JavaScript where you have things that look like an array, but they're not actually an array because they're not on the array prototype chain. So it'll have like a length property, and you're thinking, oh, great, it's an array. But then you do a for each, and the browser blows up because it's not an array. That's what file list is. File list is an object with a length property on it. So when you iterate through file list, you should do like a for loop. Don't do for each or something like that. Or don't count on any of the other methods that would normally be available on an array to be available with file list. So you get a few things here. You get the files property, which will, like if the user, if you have a file input element and the user selects some files, you can access those files via the files property on the input element. Then there's this multiple attribute, which allows you the user to select multiple files. And then there's this Chrome-specific attribute called WebKit directory, which I'm going to talk about shortly, which allows you to select entire directories and associate them with the file input. And I have sort of an exclamation point there. Maybe you shouldn't be using that because it's not part of the spec. It's specific to Chrome. It's something they threw in there, and Mozilla has been very clear on the fact that they are not even going to consider adding that to Firefox because it's not part of the spec, and they're sticklers.
Are directories considered files too?
Well, if a directory does not have any files in it, then it will not be part of the request, and it will not be accessible. So, no, not exactly. But when you select a directory, like the files in that directory, the name property of so you've got these multi-part boundaries in the request, and each file is going to be a different multi-part boundary. The name property of the multi-part boundary will reflect the relative path of that file. So when you get the request server side, you can determine, relatively speaking, where that file existed in the structure of files. You can recreate it server side. And that's sort of what I'm going to do here when I go over the WebKit directory attribute. So let's just, you know what, let's take our form example here, and let's rewrite it to use XHR and the file API. So we don't need this iframe anymore. We don't need this target anymore. We can keep the submit. We'll intercept the submit event and prevent it from actually submitting. Let me just add whatever. So let's do this. We're going to listen for the on submit. I'm going to need that's probably. Let's not submit the form, and then let's deal with the file. So I mentioned that the file API gives you this files attribute or files property on an input element, on a file input element, which is nice. And we're going to sort of be dealing with that file list in the next example, but we're going to keep things real simple here. We already have an existing form. So what we really want here is we just want to take the contents of this form and just send it to the server. And you can do that really easily with the file API and form data. So we're going to create this form data. Let's, since we're going to be using this form again, let's do this. And we're going to pass this form into the form data object. And what it's going to do is it's going to parse this form for us. And when we send this form, it's going to look exactly like it was when we submitted the form in our original example. And that's really all we have to do here. So
the form data is going to set the MIME type of the request for you, right?
Yes.
So you don't need it up there anymore.
Right. You can keep it, but it doesn't really matter. Sure. Yeah. And that's not necessary anymore. In fact, the action also isn't necessary because we're using XHR here. The method isn't necessary, but just for simplicity, I didn't remove those things. But you're right, you don't need any of that. So let me just clear out some of these files here. And I think that's all we need to send this. Open send, it seems like it should work. Sure enough, there's our request. You can see looks just exactly like the form submit, and there's the file. So great. But we can only select one file here at a time, which isn't very useful potentially. So if we want to allow the user to select multiple files, all we do is add this multiple attribute, and now we can send multiple files. Refresh. And both of those files are going to be part of the same request by default. So here they are. Now, this WebKit directory attribute that is specific to Chrome is kind of neat, but it doesn't. I mean, the Mozilla people are right. It has some drawbacks, and the big drawback is if you have let's say your directory is on like a high latency drive. If you're like selecting a directory with like 1 million files in it, the UI is just going to hang while it's parsing that, which is not good. We're not going to worry about how practical that is here. We're just going to use it because it's your users might ask for it, and once a user asks for something, you have to do it, right? So we're just going to select this bootstrap slider directory, and we're going to go ahead and send that. And now we have the multi-threaded pull request with all the files in there. And we've easily reconstructed the directory structure on our server by handling the request. And here we have everything that was in there. Gonna clean up again here. So the next thing I'm going to show is handling drop files, and this is another way you can get access to a file list that represents files that a user selected. So if you have ever worked with like the drag and drop API in HTML5, it's kind of a mess. So we're going to keep it real simple here. I'm just going to do the most simplest possible like drag and drop support here that I hopefully won't screw up. But the first thing we're going to do is we're just going to allow the user to drop some files in the document. And we're going to create an unordered list, and we're going to display the names and the sizes and the types of each file they've dropped. And then after that, we're going to zero in on image and video files. And for each image file and video file, we're going to actually render it in the browser. For images, we're going to render them in an image tag, and for videos, we're going to render the drop videos in a video tag and have it autoplay. So let's extend this a little bit. Well, actually, we won't extend that. We're going to create a new file because we're dealing with drops now. So let's create our drop zone. The simplest way to do this is document drag leave on drag leave, or on drag over. I can't even keep it straight myself. And due to the wonderfully constructed drag and drop API, in order for this to work, we have to do prevent default here. And we don't need anything in the drag over event, but we have to do this. For the most part, if you're dealing with drag and drop, use a plugin. On drop. And we also need to do an event prevent default on this one too. Otherwise, when you drop the file, the contents of the page will be that file. So now on this event, when a file is being dropped, there's a data transfer interface. And that data transfer interface is going to have a file list, the files property, just as you would have on the file input element. And that's how we're going to get our files that the user dropped. So what we're going to do first is, let's have an unordered list here. And let's iterate through the files. And let's just print information about those files in the list. So and this list will become important later as we get through the demo. Let's add this. Okay, I think that's going to work. So let's drop this image here. Okay, that worked. And this thing here, great. So we're seeing information about the files we dropped. Now let's actually zero in on images and videos and actually render them in the browser. And that is surprisingly easy to do. So let's first let's look at images. Anything that starts with image / is an image. And let's create image element. Set the source to the a object URL for that file, which we know is an image. It. So now for images, it didn't work.
You need to change the index of condition. Check for 0.
Oh, that's true. I was thinking contains or starts with. Now it should work. There we go. Great, so we have. Oh, what happened there? All right, real interesting. So let's do something a little bit more visual. Let's take a video and render it into a video element and then have it play automatically. So for everything that's a video, this is if we want several videos playing on the same page. Yes, I spent a long time on the CSS. Okay, so that should be good enough. So let's drop some videos. Simpsons trailer. This the standard video for testing video stuff, Big Buck Bunny. Now we have 2 videos playing in our browser. Big Buck Bunny. It's like if you go to the Quirks mode HTML5 video page, you'll see all these Big Buck Bunny videos for testing like the different codecs to see, you can sort of see if your browser supports them. I just grabbed it from there. The Simpsons one, I don't know where I got that. We can watch more movies if you want. So, that's kind of interesting, I guess. But, maybe we should do something a little bit more realistic. And, obviously I'm not going to develop a full-scale production-ready web application up here. I'm sort of giving you some seeds. But something interesting you might want to do is, let's take a look here at when we drop a file without an extension. So the browser has this type, this type property, or the file object has a type property. So this file here, this MadJS file, it's a JPEG. Trust me, OS X knows it's a JPEG. I do. If we drop it here. So the browser is telling us that the type is an empty string, and that gives us an idea as to how the browser determines the type of a file. It doesn't analyze the file, it looks at the extension, and it looks at a map of extensions to MIME types, and that's how it comes up with that type attribute. So pretty primitive, but for the most part useful. However, let's say you're dealing with a bunch of files or any files that might not have extensions, and you want to properly identify them, maybe render them in the browser, or maybe you want to know if you should try to scale them or allow the user to crop them or whatever. You want to know if they're images. So one way to do that is by using file reader, and that's the next thing I'm going to talk about here. So I mentioned earlier that you could use the slice method on the blob prototype to slice off the first several bytes of a file if you're only interested in those, and this is the scenario where that's important. So let's say we have a really big file. We don't know if it's an image. This type property on the file object is an empty string. We want to find out if it's an image. So maybe we could have a mapping of magic bytes to MIME types. And I just happen to know that this is something FineUploader does. I just happen to know that the magic bytes for a JPEG, which this happens to be, I know it is, are the first 3 bytes are FFD8FF, which is 255, 216, 255. So let's slice off the first 3 bytes of every file we get that has an empty string type, and let's see if it's a JPEG. So we can do that also. That's also not very difficult. Let's sort of refactor this code a little bit. We're going to, now file reader, reading a file is an asynchronous process, so we have to take that into account when we're working with it. So we're going to have this get type method we're going to create, pass in the file, and if you're dealing with asynchronous stuff, generally speaking, you want to use promises. Keep it simple. We're just going to use the callback here. So we're assuming that our get type method is going to call us back with the actual type of the file. So let's move that up into here, and we'll create our get type method. So if we already know the type of this thing, that will work. Just don't return it. Call back with the type. But if we don't know the type of this, if it's an empty string, let's parse it. So I already mentioned what the magic bytes, the first 3 bytes of a JPEG file are. So let's just create that sort of signature array right there. So we'll call it JPEG magic bytes, 255, 216, 255. And what we're going to want to do, and this will become more clear later, is we want to turn this into a typed array, specifically an unsigned 8-bit integer array. We're going to do that here. We need to do that. And now we have our file here, so we need to read the first 3 bytes. So let's construct our file reader. And the file reader will allow you to read a file in various formats. In this case, we're going to read it as an array buffer, and then we're going to turn that array buffer into a typed array, a uint8 array. So we can easily compare that with this JPEG magic bytes here. This is what's going to be called after the file has been read. Read as array buffer, and here we're going to slice the first 3 bytes off the file, because that's all we care about. There's no sense in reading the whole file into memory. So this is going to be this is here is going to be an array buffer. And what we want to do is we want to turn that into a typed array and compare that with a JPEG magic bytes. And if it's a JPEG, then we're going to call our callback back with the image/JPEG MIME type, because now we know it's a JPEG. So let's do that. And the easiest way to compare these 2 types is probably not the most efficient, but the easiest here is to stringify them. Now we're comparing 2 strings. It's kind of a long string, but so if that's true, we're going to call our callback back, and we know it's an image. So this should work now. If I didn't miss anything, looks good. Drop MadJS back in there, and we have a rendered JPEG.
Where's the type?
What's that?
Where's the type?
The type, well, if you look back at the code, we were looking at that type by actually accessing the type property on the file object. So the file object has the incorrect type, but then lower down here, I actually calculated the type by looking at the file itself. So if we sort of move this line down a little bit. Well, I think you get it. I'll show you right. There you go. So that's something potentially interesting you can do with the file API. There's a lot of things you can do. For reasons of time, I'm not going to cover this last example because we're running close to an hour now. And there's one last thing I want to talk about, and that's the file system API. And I'm not going to show any examples of that because that's a little bit more involved. But one thing you should be aware of, well, let's talk about the file system API is first of all. The file system API allows you to read and write files to a sandbox file system, a sandbox area of the file system. And that sounds pretty cool, and it is. But unfortunately, the adoption rate was very small. Chrome was literally the only browser that adopted it. And no, all the other browsers, Mozilla has actually said they will never implement the file system API. They're focusing more on IndexedDB, which does a lot of the things that the file system API can do. So they're not focusing on it. And as of April 14th, or recently, the file system API is considered dead. It's going to be removed most likely from future versions of the spec. So I don't know what the fate of the file system API is in Chrome. There's some cool stuff you can do with the file system API. One of the biggest things that IndexedDB doesn't solve is you can handle drop files, drop folders. So if the user drops a folder in Chrome and you make good use of the file system API, you can get a handle on all the folders and files that have actually been dropped by the user, and then upload them or do whatever you want with them. That is made possible by this entry interface, which the file system API reveals. So there's a directory entry, there's a file entry. So that allows you to, it gives you asynchronous access to parse the file system, to parse the directory that has been dropped. So you're not tying up the UI thread necessarily. So that is, I'm not sure what the fate of that is in Chrome. I think it's kind of cool, but I don't know if it's going to stick around. You can also cache larger files for later use using the file system API. So I've got some links at the end here. I can send those out via comment. Just some links about some of the things I talked about. If you have any questions about the file API or file uploader or widen or whatever, you can see me after the meeting, or you can ask me now if you have any questions.
Are there any performance issues of uploading like very large files, like gigabyte file?
Well, I guess it depends how you're uploading them. If you're just taking the actual file, putting it into a form data object and sending it, most likely not. And there isn't really any noticeable performance hit with sending that file via XHR. That's an asynchronous process, and you're not loading that entire file into memory. So the process of simply uploading the file, regardless of how big it is, you probably won't notice any performance issues. Now, if you're taking that file and slicing it into smaller pieces, that might take some time, but if you're dealing with an actual file, it's ostensibly all it's doing is it's sort of slicing it up, it's slicing that pointer up and creating new pointers to different segments of the file on disk. So I haven't seen any noticeable performance hits when you're doing something like that, even with a large file. Now, if you're reading a large file, that will have a performance hit potentially. Okay, so I think you're up, Mark.